Okay, the next molecule that we have drawn in the class is CH3I. So it's very easy. The Lewis structure for that was like this. The number of the domain, you have 4 domains, one here, 2, 3, 4. So 4 domains, 4 bonds, no lone pair, so domain becomes 4, the hybridization becomes sp3. So both electronic geometry and molecular geometry are the same because you have no lone pair and they are tetrahedral. So for the tetrahedral arrangement, we draw the central atom, one domain at the top, one domain here, one domain is coming out of the board, one domain is going inside the screen. So one of them is iodine. 3 of these domains are single bond with the hydrogen, and the bond angle is 109.5 degrees. Okay, the next molecule that we had is carbon dioxide, CO2. The Lewis structure for the carbon dioxide is like this. So how many domains do we have? One domain here, one domain here, no lone pair. So you have 2 bonds, no lone pair. Domain is 2. Hybridization is sp. Electronic geometry is same as molecular geometry, and it is linear. So when you want to draw the molecule, you have one domain here, one domain here. These domains are double bond, and the angle is 180 degrees. The next molecule is OF2. Okay, so the Lewis structure was like this. How many domains we have here in this molecule? Single bond here, single bond here, 2 domains, 2 bonds plus 1 lone pair here, 1 lone pair here. So 2 plus 2. So the number of domains is 4. So you have 4 domains around the oxygen. So when you have 4 domains, the electronic geometry is tetrahedral. Okay, so for the tetrahedral structure, you have central atom. One domain here, one domain here, one domain is going or is coming out of the screen. One domain goes inside the screen. 2 of these domains are single bond with the fullerene. But the other 2 domains are lone pairs. So I delete the bond, I put the lone pair. I delete this bond, I put the lone pair here. Okay, so the molecular geometry, as you have probably guessed, is bent. Another name for the bent is V-shaped. Okay, we can say it's bent or V-shaped, and the angle reduces to 105 degrees approximately. Okay, the next we have drawn NH4 plus. So it's polyatomic ion. As we said in the class, polyatomic ions are charged group of the atoms which are bonded to each other covalently. So you have nitrogen which is covalently bonded to 4 hydrogen atom and it has the charge. So we call it polyatomic ion. Okay, so this is the Lewis structure for NH4 plus that we have drawn in the class. So the procedure for finding the electronic geometry, molecular geometry, and bond angle for these polyatomic ions are exactly the same as the molecules. So let's determine the domain that we have here around the central atom. This is 1, 2, 3, 4. So you have 4 bonds. You don't have any lone pair, so it becomes 4 plus 0 becomes 4. When the domain is 4, hybridization is sp3. So the electronic geometry and molecular geometry would be the same because there is no lone pair on the central atom and it is tetrahedral. So we can draw the molecule here, or the ions, better to say. So you have nitrogen, one domain here, one domain here, both of them are on the screen. One domain is coming out of the screen, and one domain goes inside, and have hydrogen, 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 and the bond angle for the tetrahedral arrangement is 109.5. Okay, you can also put it in the bracket and write the positive here. Okay, the next molecule, or the next one, is also polyatomic ion, is PO4 3 minus. The Lewis structure for that was like this. So you have oxygen, 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 and the charge is 3 minus. Okay, so how many domains do we have around the central atom? One domain is here, 2, 3, 4. So the domain, you have 4 bonds, no lone pair, so the domain is 4. Hybridization would be sp3. Electronic geometry is same as molecular geometry. It's tetrahedral. Okay, and how we draw that one? You probably know right now. You have central atom, one domain at the top, one domain in this side, one domain is coming out of the board or a screen, one domain goes inside the screen. So you have O, O. Okay, it's not necessary if you need only to draw the shape to write down the lone pairs, but it's very necessary for the Lewis structure to draw everything, the lone pairs and everything. But I draw it here. The angle that you have here is 109.5 degrees, and these ions has 3 negative charge. Okay, the next ion is SO3 2 minus sulfite ion. The Lewis structure for the sulfite ion was like this. So how many domains do we have here? We have 3 bonds, 1, 2, 3, plus 1 lone pair here. So 3 plus 1, you have 4. When the domain is 4, it means the hybridization was sp3. And for sp3 hybridization, the electronic geometry is tetrahedral. But because you have 1 lone pair, the molecular geometry and electronic geometry are not same. And when you have 1 lone pair in the tetrahedral arrangement, the molecule becomes trigonal pyramidal. If you want to draw the shape of the ion that you have here, I draw all of the 4 domains. 1 domain here, 1 domain here, 1 domain is coming out, 1 domain is going inside the screen. 3 of these domains are single bond with oxygen. The domain that you have here at the top is actually the lone pair. So I delete this one and I put a lone pair here. So you can see the structure becomes pyramidal. And in the pyramidal, the angle decreases from 109.5 to around 107 degrees. Okay, the next molecule that we had was BF3. Okay, the Lewis structure was like this. Okay, if you remember, we said this molecule is electron deficient, okay, because the boron, which is central atom, has not reached to the octet. Actually, the boron is here in group 13. At the top of group 13, you can see the boron here. It has 3 valence electron. If it shares all of its 3 valence electron, it can reach to the 6. So it cannot be octet. So that's why we call it electron deficient. Okay, so anyways, let's find the number of the domains. We have 3 bonds. 1, 2, 3, no lone pairs. So 3 bonds, no lone pair. The domain is 3. When the domain is 3, the hybridization is, the hybridization is sp2, and the electronic geometry and molecular geometry would be trigonal planar. Okay. As I said before, trigonal planar molecule is like the Mercedes-Benz logo. So you have central atom, 1 bond at the top, 1 bond here, 1 domain is here. So you have single bond with fluorine in all of these domains. And the angle in trigonal planar is 120 degrees. The next molecule is BeCl2. So let's draw BeCl2. Again, this molecule was electron deficient because beryllium cannot reach to the octet. If you look at the periodic table, the beryllium is here in group 2. It has 2 valence electrons. If it shares all of its 2 electrons, it can reach to maximum 4 electrons. So it cannot be octet. Okay, the domain for this one, you have 2 domains, 1 bond here, 2nd bond here, and no lone pair. So 2 plus 0 becomes 2. When the domain is 2, the hybridization is sp. Electronic geometry and molecular geometry would be linear for the sp hybridization. And for the linear molecule, you draw the central atom, 2 opposite domains. So one of them is single bond with the chlorine, another one is single bond with the chlorine, and the bond angle is 180 degrees. Okay, the next molecule is SO2, sulfur dioxide. Okay, so the sulfur dioxide had 2 resonance structures. Okay, we said for some of the molecules, only one Lewis structure cannot represent the molecule very well. So we have several Lewis structures, and the real structure of the molecule is average between all of these structures, which we call them resonance structures. Okay, so for the SO2 molecule, I draw the resonance structure for that. Okay, so one of the resonance structures was like this. It had resonance with another structure. Okay, so this is the SO2 molecule. So when you want to draw the shape of the molecule and determine the bond angle for the molecule which has resonance structure, it's enough to take only one of these structures. Okay, so I can use this one for determining all of this. So how many domain do we have in this molecule? So we have 1 bond here, 1 double bond here, and 1 lone pair here. So the total domain is 2 bonds plus 1 lone pair is 3. The hybridization would be sp2. For sp2 hybridization, the electronic geometry is trigonal planar. But the molecular geometry for that, okay, we have lone pair, so you must probably know that the molecular geometry is not same as the electronic geometry. Again, and for trigonal planar, this is your central atom. As I said, it's like the Mercedes-Benz logo, so you have these 3 domains. So for this molecule, this domain is double bond with oxygen, Sorry, you have only 2 lone pairs here for this oxygen. And this one, single bond with the oxygen. And the domain that you have here is a lone pair. So I can put the lone pair here. So how would be the shape of the molecule? The shape of the molecule becomes bent or V-shaped. But the angle that we have here is different from the bent or V-shaped molecules that we had earlier. Here, the angle for the trigonal planar was 120. It decreases a little bit and it comes to around 117 degrees. Okay, so if you have the bent molecule, the angle depends on the electronic geometry. If the electronic geometry is trigonal planar, the angle is 170 degrees. In the previous example, you had the bent molecule, but the electronic geometry was tetrahedral. In that case, the angle is 105. Okay, so let's move on to the next one. It's sulfur trioxide, SO3. It also has 3 resonance structures. I draw one of them only here. Okay, the resonance structure for that is S, O, O, O. This is one of the resonances. Okay, let's draw the rest of them. So the next one, you have the double bond here. So the position of the double bond change in the resonance structures. And for the last one, the double bond is with the sulfur and oxygen at the right side. These are 3 resonance structures for SO3 that we have. Okay, so I pick one of them, this one, to determine the domains that we have. So how many domains do we have here? 1, 2, 3 bonds, no lone pairs. So the domain is 3 plus 0 becomes 3. When the domain is 3, hybridization is sp2. And when you don't have the lone pair, electronic geometry and molecular geometry is the same. And for sp2, it is trigonal planar. So your molecule, you have S here, one domain here, one domain here, one domain here. One of these domains is double bond with the oxygen, single bond with the oxygen, single bond with the oxygen. And the angle that you have here is 120 degrees.